G'day Year 10. Today we're going to have a look at exponential equations. These are equations where x is in the exponent, or index, or power, or whatever you'd like to call that. So a simple exponential equation is in the form a to the x equals b, where a is greater than 0, so we have to have a number there that's greater than 0. And also b will be greater than 0. A cannot equal 1, otherwise 1 to the power of x can be very hard to solve that for other things. There is only one solution to exponential equations when they are in that form, meeting all of those criteria. Many exponential equations can be solved by expressing both sides of the equation using the same base. That's what we're going to do. You're going to find this pretty easy. We'll jump straight into some worked examples. So I'm going to solve for x in each of the following. So 2 to the x equals 16. What's that equivalent to? Well, I would say something like 2 to the x. Now 16 is a power of 2. 2, 4, 8, 16. It's the fourth power of 2. 2 to the x equals 2 to the power of 4. Therefore, if I have the same base raised to a power on each side, the powers must be equal if it's an equation. So x is going to equal 4. Let's have a look at b here. 3 to the x equals 1 over 9. Well, 9 I could write as 3 squared. This is almost good, but I don't have 3 to the power of something equals 3 to the power of something else. You're going to have to think back into your memory bank and think, what is it that I can do to get a number off the bottom? How could I write it as an index instead using indices? That's right. 3 to the power of x. 1 over 3 squared, that's the same as 3 to the negative 2. So x would equal negative 2. What's that index law? A to the negative m is 1 over a to the m. Just a reminder in case you'd forgotten that one. Lucky last here. C, 25 to the power of x equals 125. Well, this is a little bit confusing because 25 squared is 625. That's not going to help me very much, but if you know your powers are 5, as you should, you're going to recognise 25. I could write that as 5 squared to the power of x. 125, well, that's 5 cubed. Using my index laws, I've got a power raised to a power. That's on the left-hand side, 5 to the 2x, and that's going to equal 5 cubed, so I can make the conclusion the powers have to be equal. 2x equals 3. X equals 3 over 2. Then you've got your answer there. There are 3 there for you to try on the left. Have a go at them right now. Pause the video. All right, so the pause is a lot longer for me than for you, although I guess it depends on how long you pause it for. Have a check of your answers there. See how you went. Hopefully you got them right. For the last one there, 16 to the power of x equals 64. 16 and 64, they are powers of 2 and of 4. So you could do it using powers of 4 or powers of 2. It's going to lead you to the same answer. Last little couple to try here. I'm going to do the one on the left. You're going to do the one on the right. 3 to the power of 2x take 1 equals 27 to the power of x. Well, that left-hand side, that base is a prime number, so it's not getting any smaller. I'm not going to reduce it to anything. 3 to the 2x minus 1, but 27's 3 cubed. So 3 cubed all to the power of x, multiply the powers. I'm going to have 3 to the 3x. The bases are the same, and they're equal expressions, so the powers must be equal. So I can conclude, okay, therefore, 2x take 1 equals 3x. Get all my x's on one side, subtract 2x from each side. I'm left with negative 1 equals x. And that'd be my answer. All right, pause the video again. You get to try the one on the right. Good luck. All right, have a look at your answer there. See how you went. Hopefully you got x equals 1. If you substitute it back in, you'll see 5 to the power of 2. That'd be 25. 25 to the power of 1. That'd be 25. That would work too, wouldn't it? Don't forget your quick points activity. Something a little bit different there for you today. Some of you are sending through really good questions. If you're looking for those extra upgrade activities, we won't necessarily have filled them all in yet. We're doing our best to go back and fill it in while still building all the content. If you get lucky and get through an activity before there's content there, you can always check back later. Otherwise, maybe you've earned yourself a well-earned break, and for that one at least, you can skip over doing anything extra. But you know me, I'm going to find some maths and put it in there. So check back and you can always fill it in later. Please keep filling in those forms. We're only getting a small-ish percentage of you filling them in. We'd really like the feedback from all of you. So once you finish an exercise, click on there. Let us know how you went with the activities. Keep your questions coming into the collaboration space as well. We have, there's one question that's been in there. How do I find the 7 question surveys? They are at the top of the page. There you go. There's a good answer. We want more of those maths-related questions as well. If you've got a question like this, chuck it into Teams. Some of us will see it there too, but in here is fine as well. Keep up the great work. We will see you next time. Thanks, guys.